This is a follow-up video to what we looked at yesterday. This is the second day of U substitution, and all I want to do in this video is basically go over some of the homework problems to give you some reinforcement to see if you understand what you're doing. But in particular, I've highlighted, first of all, 3 different problems involving e to the x. In the notes in class, we didn't look at any of those problems, although they were assigned, and they follow the same principles of using U substitution. So let's take a look at number 65. Our goal here is to find the antiderivative of the given function. Notice in this problem that there is an inside function. Clearly, e to the x plus 1 is on the inside of the power of a square, and then we have an outside function, which is e to the x. So remember, in U substitution, I'm going to move this little box here out of my way. In fact, I'll just put it right there. In U substitution, we're going to let u equal to the inside function, so u is equal to e to the x plus 1. We're going to take the derivative of both sides, so we get du is equal to e to the x dx. I'm going to move this out of my way too. And then we're going to do the U substitution, so we're going to rewrite a new integral, but this integral is going to be in terms of u instead of in terms of x. Now notice that u will replace, the variable u will replace everything on the inside of the parentheses, and then notice that my e to the x multiplied by dx gets replaced, in this case, with du. Okay, so when I make that replacement, my integral in terms of u will be the integral of simply u squared du. When I find the antiderivative of that, I get u cubed over 3 plus c. But remember, we wanted to find our indefinite integral in terms of x. So now I'm going to make my resubstitution. So in place of u, I'm going to go back over here, and now I'm going to substitute e to the x, e to the x in place of u. So my antiderivative is going to be e to the x plus 1 to the third power over 3 plus c. So that's the antiderivative of this particular given function. Again, looking for the inside, looking for the outside. All right, let's take a look at number 67. We're going to follow the same idea. So in this case, we have our inside function and we have our outside function. I'm going to let u equal to the inside function of 1 minus e to the x. I'm going to take the derivative of both sides, so I get du is equal to, the derivative of 1 is 0, and the derivative of negative e to the x is negative e to the x dx. So when we sneak a peek back over to the problem, when I'm looking at the entire integrand, notice that there's no negative. So I'm going to divide both sides by negative 1 and get negative du is equal to e to the x dx. So I'm going to replace my inside function with u. So u is going to go where the 1 minus e to the x was in the original problem, and then my e to the x multiplied by dx is going to be equal to negative du. So I'm going to make that replacement. I'm going to write an integral that is now in terms of u. So the inside function, remember we said, was going to be replaced with u. I'm going to go ahead and write that as u to the 1/2 power. The negative that's with the du, I'm going to put the du in the back, and I'm going to put the negative out front. I'm going to find the antiderivative, so I get u to the 3/2 divided by 3/2. There's my negative, plus c. So all this does is it allows me to take a complex variable and change it to a simple variable. That's why it's called U substitution. We're substituting out the variable. Now the last step is to resubstitute. So now I'm going to replace 1 minus e to the x into the u. So my answer for the antiderivative of this function is negative 2, 1 minus e to the x to the 3/2 power over 3 plus c. So what you see in red is my U substitution, my work that's helping me to actually find the antiderivative of a more complicated function. Problem number 69, there are a couple of things we can do in number 69. One strategy would be to do a rewrite and divide everything by e to the 2x and make this 5e to the negative 2x minus e to the negative x dx. Now if I'm going to use the u substitution strategy, if I rewrite it this way, then I really have to do u substitution twice. Alright, so I mean you can do that, it's no big deal, but I'm going to keep the problem as it was written. Let me get my eraser here and erase what I just did there. And so I'm going to let u equal to, in this case I'm going to let u equal to the denominator because it's the more complex function. So I'm going to let u equal to e to the 2x, and then I'm going to let du, find the derivative of both sides, so I get e to the u du, so 2e to the 2x dx. So actually in this problem I may have to separate it because when I try to, let's go on and see what happens. This is a good example of if you go down the wrong path you may have to change directions and do something different. So when I try to find my replacements, notice what will happen here. Oh, this will work out okay. If I make my replacements, in place of e to the 2x I'm going to substitute u. So I have over u. Now the 2 here, notice I don't need that 2, so I'm going to divide both sides and I get du over 2 is equal to e to the 2x dx. Now when I come back over here and I look at my numerator, that doesn't really help me very much. Yeah, I can put a 1/2 here and I can put a du in the back, but that doesn't really help me replace the 5 minus e to the x. So if that substitution doesn't work, then I'm going to go back, even though I originally changed my mind, it looks like that's the direction that I'm going to have to go in. Alright, so let's regroup here. In fact, let's get rid of all this stuff out of my way. Let me recopy the problem here. So in number 69 we have, let's do 69 right here. In number 69 we have the integration of 5 minus e to the x over e to the 2x dx. So I'm going to rewrite that as the integration of 5e to the negative 2x minus e to the negative x dx. So I divided everything by e to the 2x. I'm going to do two u substitution problems. So I'm going to start with the first expression. Well, let's do one more thing. I can rewrite this as 5 using integral properties, e to the negative 2x dx minus e to the negative x dx. So now I'm really, it definitely looks like two u substitution problems. So in the first one, I'll call this number 1 and this number 2. So my first u substitution, I'm going to let u equal to the inside function, and the inside function, or let e to the negative 2x du is equal to e to the negative 2x times negative 2 dx. Let me clear that up a little bit. So the derivative du is equal to e to the u multiplied by the derivative of the power, and there's my dx. So when I do my u substitution there, I will have 5 on the outside. And one more thing, notice again, I don't need the negative 2, so I'm going to divide both sides by negative 2 and get it out of the way. So I have my 5 out front. The integration of, this is where I'm making the u substitution. So u goes in place of e to the negative 2x, so I have u du in the back, and I'm going to take that negative 2 and I'm going to pull it out front and divide it by the divide the coefficient by that. So when I find the antiderivative there, I get negative 5/2 u squared over 2, which is negative 5u squared over 4. So when I go back and make my replacement for the first integral, I get negative 5. Remember that u is equal to e to the negative 2x, so I get e to the negative 2x squared over 4. All right, now I'm going to do the u substitution for the second term. So in that one, I'm going to let u equal to e to the negative x. du is equal to negative e to the negative x dx. I don't need that negative, or actually I do, it's sitting right there, so I'll keep that. So when I make my u substitution, the integral is u du, and when I find the antiderivative, I get u squared over 2. So when I resubstitute, I will get plus, I'm going to put e to the negative x back in place of u. I get e to the negative x squared over 2 plus c. A little bit of cleaning here is going to give me negative 5e to the negative 4x. When you have a power to a power, you multiply, plus e to the negative 2x over 2 plus c. So that one was a little bit involved. All right, now I want to pick out some of the ones from earlier in the homework, just so you can see as many of these as you can and hopefully get some help. I'm going to pick some that I think you might find a bit more challenging. So let's start. One of my favorites is number 29. In problem number 29, we have x squared plus 3x plus 7 over, I'm going to go ahead and rewrite the square root of x as x to the 1/2 power. Now when you're thinking about u substitution, you need to remember that that's simply a strategy. It's not the only strategy. You don't forget your simple techniques. And in this case, this is the simple technique problem involving algebra. U substitution, I don't think, is going to be very friendly to you here. All you want to do in this problem is to rewrite. I'm going to divide every term by x to the 1/2 power, so I get x to the 3/2 power, because 4 halves minus 1/2 is 3 halves, plus 3x to the 1/2 power, plus 7x to the negative 1/2 dx. And then from there, you do just normal term by term anti-differentiation. Increase the power, divide by the power, increase the power, divide by the power. So this is not a u substitution problem at all, even though, because it's in this section, a lot of people try to make it into a u substitution problem. Another example of something of a similar nature, let me clear this, is number 33. In number 33, you have the integration of 9 minus y. Again, I'm going to change that square root of y into y to the 1/2 power dy. U substitution is unnecessary. Use your basic algebra skills, distribute, and I get 9y to the 1/2 power minus y to the 3/2 power, and I do normal anti-differentiation term by term. I do not need u substitution for number 33. Let's take a look at number 25. That one looks kind of interesting. I know I'm kind of skipping around here, but I'm just looking at the problems and seeing what you might run into. I have 1 plus t to the negative 1. Actually, let me change that back. I want to as 1 over t. I'm going to write it as the problem originally had it. 1 over t multiplied by 1 over t squared. Again, same thing. Distribute, distribute, and you get the integration of 1 over t squared plus 1 over t cubed dt, which is the same thing as t to the negative 2 plus t to the negative 3 dt. So you're going to use a normal integration strategy. You're not going to need u substitution on this problem at all. So let's do a problem that actually requires u substitution. Let me clear my board here. Let's take a look at problem number 17. Number 17, we are finding the antiderivative of 5x times 1 minus x squared to the 1/3 power, because it was the cube root of. We can't multiply this out because we have a cube root there. We can't take the 5x in, so we have an inside function and an outside function. So there's my in and there's my out. So I'm going to let u equal to the inside function, 1 minus x squared. Take the derivative of both sides, and I get negative 2x dx. I look back over here at my integrand. I don't see a negative 2, so I'm going to get rid of it by dividing. Du divided by negative 2 is equal to x dx. Now the 5 is a coefficient, so I'm going to bring it out front. I'm going to write my integral in terms of u, so there's the 5, the coefficient. I'm going to replace 1 minus x squared with u, so I get u to the 1/3 power. Then I still have an x and a x multiplied by dx that has to be replaced. And x multiplied by dx gets replaced with du over negative 2. The du's in the back. The negative 2 is out front with the coefficient. There's my negative 5/2. I'm going to find the antiderivative, increase the power by 1. I get 4/3 divided by 4/3. And there's my plus c. So when I clean that up and I come back in terms of x, I'm going to have negative 15. In place of u, I'm going to substitute my 1 minus x squared back in to the 4/3 power divided by 8 plus c. Okay, there's u substitution. Let's do one more problem. Let's do a trig problem. I don't know. Let's do, I like all of these. Let's do number 57. Number 57, you have the antiderivative of sine 2x cosine 2x dx. Now, my two expressions that I'm multiplying by together are sine 2x and cosine 2x. Now, when you're doing u substitution, there is the possibility of choosing the wrong thing for u. So I'm going to purposely choose the wrong thing for u to show you what happens and what you do if that occurs. I'm going to let u equal to, let's pretend that I think the inside function is the angle of 2x. So I take the derivative and I get 2 dx. I don't see a 2, so I get du over 2 is equal to dx. So if I make that replacement, I end up with sine u cosine u, 1/2 out front and a du in the back. Well, notice that doesn't move me any closer to finding the antiderivative because I don't know the antiderivative of sine u cosine u. So if that happens, it just says you picked the wrong thing from u. It's not completely wrong, you just made a bad pick. So go again. This time I'm going to let u equal to either sine of 2x or cosine of 2x. Now think ahead. The derivative of sine is cosine, and the derivative of cosine is negative sine. So it really doesn't matter which one I let equal to u. I'll be okay either way. So I'm going to let u equal to sine of 2x. The derivative of sine 2x is 2 cosine 2x by the chain rule. I don't need that 2, so I'm going to pull it out front and divide. Then I'm going to make my replacement, so I'll have a 1/2 out front. In place of sine 2x, I'm going to have a u. Whoops, I forgot my dx. In place of cosine 2x dx, I'm going to substitute my 1/2 du. I'm going to find the antiderivative, so I get u squared over 2. I'm going to make my replacement back, so in place of u, I'll have sine 2x, so I'll have sine squared 2x over 2, which cleans up to be sine squared 2x over 4 plus c. I'll be looking at more of these problems in class. I'll be glad to help you at lunch, but hopefully this gives you enough variety of problems that it can get you through various types.